Hey guys, here we are at the shop on a Saturday. We got a pretty awesome LT4 here. And here's our LTJL. It runs awesome. We just had it up in Utah. Callan's really ringing it out, testing it. But it is a Saturday, so the shop is closed. And I thought I'd do a shop tour because we haven't done one in a while. And guys are always asking me, what do you got going on in the shop? Now, most of you know that we mainly stay with Wrangler JKs. That's really our business, and we are hot rodders at heart, so we do a lot of other things. Here at Motec right now, we are concentrating on the JKs, so we're not really farming out into Land Rovers or hot rods yet. This is a special car to me. This is a 69 Camaro Z28. I bought this car in 1977. Really the only thing I've changed is the color. It used to be Goldwood green. Other than that, it's got the 302 4-speed Muncie M21 transmission, houndstooth interior, deluxe interior, sawtooth gauges. This is what I grew up on, is cars like this. Carburetors, distributors. You guys hear me talk about Jacobs. These are the Jacobs wires that I talk about often, and they're pure silicone spiral core metal wires. They were actually the first and only street legal metal core wires. Now, of course, the patent ran out and everybody copied them, but still, I don't think anybody is up to the level of these Jacobs wires. These wires here are probably close to 40 years old, and they still look like new. They're pure silicone. A lot of wires say silicone, but they only have a small percentage of silicone, with the rest rubber. You can tell, because like down here where you use silicone to attach the boot to the wire, if I tried to pull that boot off, it would rip the silicone off. With a rubber boot, with rubber, it's just gonna slide off. So this is my 69 Z28. I've actually got a few of these, but this was my favorite 69. Over here we got a 54, I think, Chevy pickup. This was a LS3 build in another shop. The customer's been working on it for about 5 years. He brought it here to get it running, and we got it running real quick, but then we just saw all the other issues involved. Sometimes making these things look pretty is great, but making them run is a different thing altogether. And this vehicle has got some pretty shady workmanship in it. Now, it does have a dual master. You got to remember, it wasn't long before that Camaro that we were running single masters and drum brakes. I actually have a four-wheel disc car. That's not a four-wheel disc car. And that means it's four-wheel disc brakes back in 1969. They're extremely rare. So we found that the suspension, the brake system, the wells, everything on this is substandard. This customer and his family have done like 3 or 4 conversions with us on their Jeeps. So we said, bring it on in, and we're gonna fix it up for him. I'm not sure what this is. This is an LT4, which we'll be doing a video on soon. This is the L87, which is on the road. I'll give you an update on this. It runs great. We couldn't quite crack the T93 TCM. I don't think anybody's cracked the T93 ECM. So what we got is this T87A that's been modded to mimic a T93 and is allegedly going to give us full programming functionality. So we're going to be installing that next week. Here's our LT5. Got the body on. This turned out to be quite a project. We had to fit a large oil tank, relocate the battery, polyurethane mounts, got all sorts of stuff in this one. But it's going to be pretty awesome when it's done. This is a 2-door, the 600 and something horsepower, we got it running, 660 horsepower, 7-liter LS3. You'll be seeing a video on this one soon. I'm not sure what this is. Not sure what this is. Actually, this looks like a 6-liter LS. No, it's got, well, yes, it's got an iron block, so that's a 6-liter LS. And these guys have got oil in their veins because they're here on a Saturday. Callan, what do you got here?
This is Dustin's 1972 K5 Blade.
I drove this before they tore it apart, and I wouldn't have gotten a race with a little girl on a tricycle. It was so slow. What are we putting into it?
We're putting an LT1 10-speed. We're taking out a 350 with a turbo 350.
And what are we going to do to the chassis?
We may box in some parts, but we're going to try to leave it as open as we can for flexibility.
So when you do a build like this, you got 40, 50 years of just stuff. And this one's actually pretty clean. I don't see a whole lot of rust. I used to own a wrecking yard in California, and way back in the day we used to sell these Blazers to the guys on the East Coast because they were all rotted out. But this one's really cool. And it's the same color as Bill Murray in Groundhog Day when he flew off the cliff, if you guys remember that. This should be pretty awesome with a LT1. Now, you got 4 leaf springs on this, so the suspension's probably going to be pretty floppy. You got a C-channel frame, which isn't boxed. Some of the heavy-duty frames were boxed, so this thing is going to be flexing a lot. And that engine should be about 200 horsepower, but it's really like 150 right now, I think, just because it's been hacked over the years. So when we go from that to close to 500 horsepower, it's going to be a challenge keeping this thing going straight. We used to use what were called traction bars, which mounted on the bottom of the axle there where the spring perches are. And as the spring wound up and it turned into an S, there was little bumpers that would hit the bottom of the spring and keep the axle from jumping up. My prediction is this thing is going to raise several inches when you power brake it, so we'll have to deal with that. So the guys just showed me they have these, what they call traction bars. These are very different than what we used to run. This is just going to pivot them off the front, and I'm guessing those 2 clamps will keep the axle from rotating. But I guess we'll see. So one of the challenges with these early Chevy pickups is the frames are so narrow, so it's hard to get exhaust in. You can see that the exhaust, even on this small block Chevy, it had to be notched out. So it's going to be interesting to see how tight it is on the LT1. The LTs have the air compressor down here, so we might have to go to a high mount. I'm not really sure. What are you planning on that, Kellen?
I don't know.
The early small block Chevys had Siamese cylinders, they called it, and it would get pretty hot, and the log manifolds would warp. So there was a whole aftermarket to, like when you took the manifold off, it would warp and you couldn't get it back on. So they had these spreader bars and all sorts of weird things. The modern exhaust systems are far superior. In fact, everything is far superior to this engine today. But if you think about 60 years ago, this was the height of technology. Thin wall casting, V8, high compression. The small block Chevy ruled the engine performance world for many decades. And unfortunately, it has been supplanted by the LSs and then the LTs. If you look at the drive on this, it's very similar to the Z. Now the Z has deep groove pulleys. If you look at this, you can see that the belt's flush with the pulley. The Zs would really rev up, especially the 302s. So to keep the belt from flying off, they went to a deep groove pulley. I wanted to take a quick look at this this truck. Almost all of our LS and LTs owe a lot to this truck, because this truck was actually swapped back in 1982. It is an 82 Toyota. Had a small block well, no, it actually had a V6 turbo in it, a Grand National motor for a couple of years, and then the crank broke, and the cranks broke on those old Grand Nationals because they didn't fillet them right. And of course Buick wouldn't warranty it, so I threw a small block Chevy in it of a 67 Chevelle, and it had a 283 carbureted small block in it for 25 years, almost 300,000 miles on that engine. And I eventually fuel injected it, which is pretty awesome. But in 2007, when the Gen 4 LS came out, we put a LS 5.3 in this. This is just before the JKs came out. And we had to go through a lot of R&D to get the Gen 4 LSs to work. A lot of guys were using the Gen 3s. When we got into the Gen 4s and we got into the anti-theft systems and the active fuel management and four-wheel drive low signals and security, we had to prototype it on something, and this is the vehicle we used. This old truck has got many hundreds of thousands of miles on it, and I'm going to venture to say close to 100,000 miles on this LS engine now, and we use it as a parts truck and a garbage scow. But we actually work with EFI Live down in New Zealand to develop a lot of the programming for what you guys now see in their software to support. And back then, EFI Live was pretty much ahead of everybody. I'd say HP Tuners now has caught up and surpassed them in some areas, but EFI Live is still leading in a lot of ways. And they helped us get these LSs on the road even before they had them in Australia. So it's a pretty important vehicle. these are transfer cases we pulled out, and I would say that almost the majority of these transfer cases are ORs or off-road Rubicons. I'm just going to say, you can tell a Rubicon transfer case because of this large 4-to-1 planetary. If you look at the case, well, let's look at a non-Rubicon. That's a Rubicon, that's a Rubicon, that's a Rubicon, that's a Rubicon. Let's see if we can find one that's not a Rubicon. That's a Rubicon. Okay, here's a non-Rubicon. See how the case is just one straight shot right up to the mounting surface? Well, one, you know this is early because it has the female input, and two, it's got the straight case. So that's a 241. That's a standard case that we use in our conversions. It's an excellent case, and it's stronger than this case. And the reason is, well, let's go down here. This planetary is 4-to-1 instead of 2.7, and that's putting more leverage on the gears, and we have this small input. So a lot of guys say, can I use that in my swap? Well, yes, you can. There is actually an adapter for it. But one, you don't need it because with a 6L80, you're at 4-to-1 low first gear. Most of the Chrysler transmissions are about 3-to-1. So what that means is if you got a Chrysler transmission with a 3-to-1 first gear, approximately 2.8 to 3-to-1, that's about what they run. And then you put a 4-to-1 transfer case on, you got about 11 to 12-to-1 low ratio. Well, if you got a 6L80 with 4-to-1 and then you got a 4-to-1 low range, now you got 16-to-1. And it's just too low. It's too low to get wheel speed up in mud, sand, and snow. If you just want to crawl at Moab, it's fine. But if you want to actually run trails, you're not going to be using the low range very much. Like I said, the 4-to-1 planetary is under more stress, so it's weaker, and then you got the small input. Now, guys have successfully run these in the Hemis and the LSs over the years, but the bottom line is, if you take the low-cost 241J, you got the same trans-range sensor, we'll talk about that in a second, and you throw that in your JK with a 6L80, now you got a 4-to-1 transmission and a 2.7 here, so you're right back to your 11.5 to 1 approximately that the stock Rubicon has. So you've got the same ratio as the stock Rubicon. Now you got 2 more firing pulses per revolution, going to a V8 from a V6. You've got almost double the torque, and actually a lot of the engines more than double the torque of the stock 3.8 liter. Also, we changed this small input to the larger input, and when we do, this transfer case is probably good for 450 to 500 horsepower. So there's no downside. You got the Rubicon gearing, you got the stronger input. The way this transfer case is designed, it's got a chain drive. It's not like an Atlas where it's gear drive. So it's lower friction. It does have an oil pump in the rear section, so you can flat tow it. It's just got so many advantages. Now this is the transfer case range sensor. This is where the Chevys and the Jeeps and others can differ. Some of the Chevys do have this on it, by the way, but some don't. Essentially, there's a plunger in here that goes up and down, and there's a 2-wire connector, and the TIPM in this case puts out the 5-volt reference, and as that plunger goes up and down, it's just a step ladder resistor, changes the resistance. So in each of the positions, you've got 2 high, 4 high, neutral, and 4 low, and then you have the intermediate positions. Each one is sensed by this transfer case range sensor based on the voltage feedback, and the voltage is determined by the resistance that's put out. It's really simple, but it's something you have to have, because if you don't have it, then your ESP and your dash and the 4 low signals and all that stuff just doesn't work right. So you want to make sure you run that trans range sensor. When you go to an Atlas, they run 2 TJ switches into their little module, and they kind of mix and match the signals. So basically, when anything is in low, it says you're in 4 low, and when it's in high, you're in 4 high. They don't really have all the modes like the factory single stick, because the Atlas is a twin stick. Hey, look at that, an old pressure plate flywheel. Haven't seen one of them in a while. This is our standard 6L80 adapter. We had designed this with advanced adapters. Now you can see that this transmission was modified to a 4-wheel drive. This shaft was cut off. It just sticks out a little bit from the adapter, and then there's a plug installed back down in here, there's a seal installed here, and there's another plug up here if you can't see it, and that takes your 6L80 from a 2-wheel drive to a 4. One of the things that we did in ours, we weren't really happy with the adapters that were out there. We wanted the full-size GM 4-wheel drive mount, so we had this pad cast in, and now this will support the full-size 4-wheel drive GM transmission mount. And we've been running that for a decade with zero issues. Advance did kind of throw us for a loop at one point because they changed the thread from 7/16 coarse to a 10 by 1.5, and those threads are so close that you can thread the 7/16 into the 1.5, but they'll eventually pull out. So they kind of threw us for a loop with that. So what we've done for security is we kind of just surface the top of this, and then when we run the bolt in, we actually put a jam nut on top just to make sure. A lot of guys ask if we're ever going to work on TJs. Well, the reality is we've done a lot of TJs and LJs. This is an LJ, and we would love to get back into this. In fact, we might someday. We're thinking about opening another shop up and doing LJs and hot rods and all that, because that's, like I said, it's in our blood. But right now, JKs are kind of our bread and butter. And the thing about an engine conversion is if everyone's a one-off, you know, if you do this chassis, then that chassis, that can get really costly with R&D. When you can design something and crank out 100 parts at a time and have them on the shelf, then we can do these conversions a lot more efficiently. The swap is rationalized, and we can keep the cost where you have value. If everyone is one-off, then it's really not win-win as far as the cost goes. This is an LT1. Here's our test engines. Every harness that goes out of here is running one of these engines. This is a LT, and this is an LS. We've actually installed O2s on these engines, and at one point we had cooling systems on them so we could run them, but we run it and check for codes. We check the MOCAN module, signals, all that stuff. This is our exhaust rack. We just use it for building exhaust systems. Here's our pipe bender and just some other fabrication tools. This is our welding bench. We do our TIG welding here for aluminum. This is our one of our TIG machines. This is a Syncrowave, but most of our welding is MIG. We also make all of our own hydraulic lines. This is our hydraulic crimper. The oil cooler lines and some other lines, like for rock rail coolers, we have to use these really high quality hoses, and they're pretty expensive. I don't know what they are dollars per foot, but they're not cheap. But when we're running up to 100 psi, up to 300 degrees, we've learned the hard way that you got to use the right hose and the right crimper and the right fittings, and that's what we do. So coming back into our machine shop, this is our plasma table over here. Most of our coarse brackets, like you know, transmission plates and things like that, are cut on this plasma table. There's our sandblaster. Sorry, the lights aren't on. This is one of our brakes to bend with. These are all takeoff parts, and we try to sell them as fast as we can, but the shelves just get filled up. And it's pretty dark here, so I'm not sure you guys can see. This is one of our 3D CNC machines. This is a mill, and this is where all of our billet brackets are made. Our billet brackets are pretty awesome. I'll go show you some in here in a second. That's a turret machine, a lathe with a bar feeder. We haven't really been using that. We need to get that online. That's a mill that I used for prototyping a long time ago. This is an iron worker, so this is kind of a jack of all trades. We can stamp with it, we can punch with it, we can use it as a brake. It's 80 ton, so there's not much that's beyond its capability, but we mainly use it for prototyping. We use the brake for production. This is an interesting lathe. I've had this lathe since the 1970s. It was made in 1929. It's a South Bend lathe. It was actually sold to a company called North American. They used to make P-51 Mustangs back in LA, actually in Culver City. And one day they were blowing out their stuff, and I went down and I bought this lathe. And here we are almost 100 years later, and we still use this lathe for not only just for prototyping, but for bushings and things. Now we do use a CNC machine for most of our production bushings, but that lathe has a place in my heart. We got some slip rolls and things too. We got several crate builds going on, pallet builds. This happens to be an LT110 speed. It takes quite a while to put one of these together because, like I said, we run the harness, then we wire the engine, we build this custom pallet around it. Everything's on, the AC lines, the engine accessories. We try to make it as plug and play as we can for you. Even the modules are tuned and tested. So we've got several of these LT1 builds going on. This is an interesting little device here. This is it's just an ATV that we bought many years ago, and I made a custom sprocket for it. See how big that sprocket is? It's about 3 times bigger than the original one. So the thing only goes about 2 miles an hour, but it'll push a JK. And I made this apparatus up here. It used to be adjustable, but now it's all bent up, but it still works. Here's some of our tire machines. Yes, we can do 40-inch tires. Here's one of the new LC8s or L96s I've been talking about. We got our hands on. I don't think we're going to be seeing 6 liters after these are gone. If you guys want a 6 liter, get it. As you can see, these are brand new. Now, this isn't an L96, it's an LC8, which is virtually identical. The difference is these engines were designed to run on alternative fuels like natural gas and propane. So they have non-corrosive hardware, and they're also designed to use in marine. So these engines were slated for marine use, and it's the only way we can still get them new. The supply is limited, and once they're gone, I think that's the last of the 6 liters for us. Here's one of our used 6 liters, and you can see it's actually pretty clean. One of the things you're going to notice about the 6 liter, they paint the block, but it's iron, so they tend to rust, especially if they're back east, so they're going to look kind of crappy compared to an aluminum engine. But this one's in really good shape, as you can see, and it's hit and miss right now on these because as time goes on, these have been end of lifed. And what we get, I mean, we used to get 20,000 mile engines for a song. Now we're paying double that for 40,000 mile engines if we can get them at all. So here's a typical LT1 build. I do believe this is a 10-speed. Let's take a look. Well, I'm not going to say typical because we got coilovers on this. We got well-done rock rails, and sometimes I say that in my videos, well, that can add to the time, and it does, because when you weld those rock rails on, we can't grab the body easily. But what we've done is we've made a number of different brackets to sneak around these rock rails and lift the body off, because otherwise we got to cut the rock rails off to get the body off, and we don't want to do that. So this is an LT1. We've got a 10-speed here because you can see there's no place for a dipstick tube. We got the 241J, which works fine with this combination. Even though this engine's close to 500 horsepower, I don't think we've blown one of these things up yet. Here's our tranny mount we talked about, or our transfer case adapter. You can see we're running the full-size GM transmission mount. Now, we do make these spacers, and one of the reasons we do that, and you can see my guys here ran the nut on top. It's really not necessary, but it's just an extra precaution that we take. One of the nice things about these spacers is you can raise and lower this transmission by changing that spacer. So if you need a little bit more clearance for a skid plate, you can bring it up. If you're tight to the body, you can bring it down. Now, we don't require a body lift with our conversions. The closest part to the firewall is going to be this passenger head, because you can see bank 2 is a little bit behind bank 1. So on the LS's, there's on the coil, there's a stud sticking up, and that needs to be replaced with a 6mm bolt. But this is going to be about a ½ an inch from the firewall when installed properly. Now you can see my guys have their vent tubes on here, and it goes up to the top of the head. If you get water above this, you're probably going to be in trouble. But some of you guys do prefer to run it up to the hood. That's up to you. Here's our fuel system, which is extremely simple. This is the stock tank. We don't modify anything here. This is a later model JK, I can tell, because it's got the fuel tank pressure sensor here. Now, this is our fuel tank pressure sensor, and we've been running that for 10 years. Chrysler finally stepped up and put an FTP in, but they stayed with a stupid ESIM, the EVAP System Integrity Monitor. And I'm not going to talk about that right now because it's a complex thing, but the Chrysler system is very primitive compared to the GM system. So what we're going to have here is full EVAP control. This is going to give feedback pressure on the system at all times, even with the key off. That's right, if you fill your tank up and you turn the key off and walk away, tank pressure can build up, and in the old days it'd blow out your gas cap. But now we've got a vent solenoid fitted, so that vent solenoid will blow that off. This is your tire pressure monitoring system module. We've obviously got some coilovers on this one. I'll try to tell you how this fuel system works while I'm here, because it's probably not as easy as you guys think. All this is a vent, And what that means is because you got low points in the tank, you want to vent to both sides of the tank. So we're venting that side of the tank all the way to up here, and it comes in here. Now this is important for you guys that break this tube, because you guys think this tube and this tube are the same, and they're not. All this is a vent so that we can vent the entire tank. This is obviously the large output to the evap canister. So the fumes go into the charcoal canister and get stored. This is one of the problems with some of the rear-mounted tanks is they don't run a large 5/8 inch diameter vent. They run these little teeny 5/16 vents, and then they tee them. So you don't really have a whole lot of vent going on there, and that can cause some problems filling. You can't like fill as fast. But here's the part that you need to know. This one here, which a lot of guys break off when they're pulling the body, or they just break off anyway. This one's not, fortunately. And then what they do is they take this line and they run it into here. Well, this line goes to the fuel, it's the fuel inlet. And what happens when you start pushing fuel into this big pipe, it builds up pressure. When you build pressure up, this tube now pushes the fill valve down. Once you push that fill valve down, it opens the tank up to this vent, and then this vent can vent large quantities of air into the charcoal canister. If that were not to drop and it weren't to vent, then you're just going to be dribbling your fuel in, and a lot of you guys know that feeling, especially with aftermarket tanks. This is just a vent to get the front of the tank vented. This is your fill valve control, so make sure you have that on there. When these break off, you can get like a brass pipe and some fuel proof. I think JB Weld is fuel proof, and you can put a piece of brass pipe in there to repair it, because this is welded onto the tank, and the dealer is going to replace the tank, and that's not going to be cheap. So that's how this fuel system works. And we are running full closed loop feedback evap system, which is required not only in California, but I'll tell you, I park these things in my garage and you don't smell nothing. Sometimes in the old days, I'd park my JK in the garage with this system, the old ESIM system, and I would smell some fuel. Kellen wanted me to mention, this is the new LT1 that we discussed about GM redesigning. They've changed the cam phasers. So this is the cam phaser. This is the oil pressure dual stage solenoid. This is the cam sensor. And the cam phaser, this has got continuous variable valve timing. So it's not parked or open. It's all over the place. They can make it go wherever they want based on the torque they need and the operating conditions. So they made the cam phaser in the new LT1s the same as the LT7, which is that one over there. And Cal says you can tell because these engines, and I can't see, but he says there's a plaque here that GM Performance adds, and that's one way to identify the new engine. And you can see, here's the part number of it, and here's your 3-wire high pressure sensor. We talk about this a lot. 2017, they went from a 4-wire to a 3-wire. This is the fuel rail, the back of the fuel rail. So this is your high pressure, it runs at thousands of PSI. And you think, well, you went from a 4 to a 3, you lost a signal. No, you didn't. This is actually a serial sensor. So it puts out, I think, 4 signals over a serial network between the ECM and the sensor. So we're getting a lot of information from that sensor. Buy an engine with a 3-wire sensor. You can upgrade a 4-wire engine to a 3-wire, but it's just better to buy it if you can with a 3-wire. On this L87, this MAP sensor, or mass airflow, you can see it only has a couple of wires on it. This is also a serial sensor. These used to have 9 wires on them for humidity, air intake, airflow, etc. So now it's just 4 wires and it's got more information. If we have an LT1 here, I'd show you that it had 9 wires, but I don't want to open a hood.
Aftermarket one.
So Cal wants me to show you, this is an LT4, and what's really important on these LT4s is to keep the intake temperature low. This is a pretty large intercooler. And when I talk about intake temperature, I'm not talking about the intake temperature going in the tube. I'm talking about the intake temperature after the blower, because what happens is the TVS style blower compresses the air, and when you compress air, the temperature increases. It's the same thing that an air compressor does for your air conditioning. And then it goes to low pressure, and when it goes to low pressure, it gets cold, and that's where you get your cold air from an air conditioning system. So we have to move that hot air out, and there's a cooler inside the V of the V8, and this is obviously the heat exchanger for that. So this is a intercooler pump, and that's what circulates the water through this intercooler. And anybody running a supercharger really needs to do that. I remember in the old days, some of the Sprintax and others, RIPs did not run an intercooler, and you're really limited what you can do, because if you start compressing that air more than 3, 4, 5 psi, those temperatures, we see them get up to 200, 250 plus, and then you're shoving that air into the chamber, and all that's going to do is cause pre-ignition and spark plugs to explode and possible engine damage. So it's really important that you have that intercooler. Now these intercoolers today are controlled by the computer. They turn on when they need to, and they turn off when they're not needed. This is a pretty standard small block from the muscle car era. We had an alternator. This one had a power steering pump added, and that's the only pulley that doesn't have a deep groove. I'm not sure if you can see, but look how far down the belt is on this pulley. You notice that when you spin this thing up, that pulley or that belt can stretch quite a bit and not flip over the pulley. And these V grooves, these early single V grooves, were pretty high friction, and you get 3, 4, 5 of those on an engine like some of them had in the 70s. It was just a matter of time before we went to the serpentine belt. The serpentine belt can be 4 grooves, 6 grooves, 8 grooves with little micro V's that give you the grip, but they don't have the friction and the drag. And that's important. Like even when we do our executive order builds, they test the drag on the accessory drive, and these earlier V grooves were very inefficient. But you can see the deep groove pulley on the water pump and down there in the harmonic balancer too. So this is a pretty small, standard small block. There's the Siamese exhaust manifold I was telling you about. You can see how a lot of heat would build up there. The Jacobs wires didn't care. They're pure silicone wires. They didn't care. This even has the old, it's been so long since I've seen one. If you look down there, there's a little plate on the exhaust manifold, or a spring. It's a bimetallic strip. It's made out of 2 metals, and they expand at different rates, which means as they heat up, they spin around just like the stovepipe choke. And there's a little flap in the manifold, and it helps the engine heat up, warm up faster. Because remember, we didn't have fuel injection back then, so we had to depend on mechanical devices to do that. As I walk by our parts shelf, I wanted to mention, if you look at these transmission cooler lines from GM, there's no thermostat in these. For some reason on the 8L90, GM ran a thermostat, and it's a big block, and you can see a little side tap thing. We've stopped using those, and we noticed that if we run the non-thermostat lines, the transmissions cool better. They do seem to get up to temperature just fine and burn off all the condensation. If you're living in the Arctic and your transmission never gets above 120 degrees, then you might want to consider running a thermostat. But let's go into the parts room here. Look at some of the billet brackets. I think Chris just, these are bushings here. These are all CNC made. Here's our adapter block for the Gen 5 air compressor. The guy that makes these is really amazing. He actually makes AN fittings for Arizona Speed and others. We're going to be redesigning this to make the threads inboard instead of outside for some applications. But these are all the bushings we use. Here's some of the billet brackets that we use in the Gen 4. And the billet brackets really changed the swap, because being able to run the Jeep accessories right back where they were means you've eliminated interferences like the let's grab an air. This is an air conditioning bracket, and you can see the amount of machine work that goes just into this one piece, and this is actually 2 pieces. But what it does is it puts the brackets back right where they belong, and this is going to mount like this. By doing that, you're not going to smack the air compressor on the driver low, because that's where GM mounts their air compressor. You're not going to smack it with the upper control arm. You're not going to have a problem with the power steering pump shoved into the steering gear. Then you got to run a smaller pulley, make custom power steering lines, make custom AC lines. You're actually running your stock AC hoses, your stock power steering hoses. You can run stock suspension with no lift and not smack anything. It really is the way to go. And we originally made these 10 years ago out of steel. They were flat cut and bend steel with bushings. but the billet brackets are pretty much no alignment. You just bolt them on and go. So this would be the block plate, and then your top bracket goes on top like that. Your air compressor ears mount here, and one thing I wanted to mention was if you have an aluminum block, all three of these block mounting holes are going to be used, and we supply cap head screws. I don't know where they are. They're here somewhere, to go into there. But this hole is not going to be drilled on the iron blocks. There's a boss there for it, but it's not drilled. So I get the question all the time, what do I do? Well, what you do is you mount this bracket onto your block and you line up the boss perfectly, and then you drill and tap that for a 10 by 1.5. Then you got your mounting points and you're good to go. So that's the air conditioning bracket. These are the simple power steering brackets. The LS3 is a little bit more complex because we actually integrate the JK tensioner right into it. Here we got some various brackets, Gen 5 LT brackets, ECM brackets. There's the lower spreader tube for the cooling system. There's battery trays. These are block plates, and you notice that we burn in. This is a passenger side. This is a lower bucket, and you can see all the adjustment you have on it. For that says P. I'm not sure if that's an LT or an LS. Well, it says right there Gen 5, so it's an LT. And then down here we got the Gen 4 brackets. These are air intake tubes for different swaps. Over here we got, and you can see sometimes we're running low on inventory. As fast as we make these things, it seems like we sell them. These are transmission plates. They support both the transmission shift cable and the transfer case. We've got them without the transfer case if you're running an Atlas. Here's the L bracket. So you put your transfer case cable on that, and then you get some adjustment based on which one you have. These are our valance covers. We put a Motec logo on that. It looks pretty cool. These are shims for the engine mount, so you can raise and lower your engines. They look like little Pac-Mans. These are various other brackets, air intake brackets, and this is a shield that we make for the fuel tank. So at the front of your fuel tank, a lot of you guys run skids, and what ends up happening is it exposes the front of the tank to the exhaust, and that's not just with a V8, but it's with a V6. So we make this so that you can bolt it onto your existing skid, and it keeps the heat of the exhaust off the front of the fuel tank. This is our standard transmission plate, and it hasn't changed in a lot of years. It's slotted. It's made out of 1/4 inch, powder coated with a hammer finish. It's just turned out to be so versatile that we haven't really had to do too much. This bolts to the now earlier on, you know, some guys like to weld these on to the cross member, and you can do that. But earlier on, we had various holes everywhere. We've really reduced it down to this, and it's been working for us for nearly 10 years. Here's the these are the 6L80 adapters that we talked about. Notice we got the machined pad in the bottom. We've got 2 clocking positions. I don't remember what they are. 16 degrees, 14 degrees, something like that. Here is a 8L90, 10L80 adapter. They don't look like this. They're not a big adapter. You're going to run the stock GM adapter, and this is going to bolt to it. And what it is more than anything is a clocking ring. And it does give you several positions to run the the transfer case. So you're just going to bolt this to your transfer case and then bolt the transfer case adapter to that. And that's it. You got some through studs. Very clean setup. It's, I think, 1 inch thick. Now, some of the later transmissions like the 10L80s we've seen with short splines. So what ends up happening is when you try to stick the output shaft into the input gear, it bottoms out, and the transfer case may not fully seat. So Advance also offers a couple of spacers for those. We saw that a lot in the 6L90s with that little short stub output. But for the most part, you don't need that. And this is our input gear, and this is a 6L90. Look how big that is. And I think you guys can all understand that we don't really need to run the 6L90. It's huge. This is the standard, our standard gear here. And this is considerably bigger than the stock JK. So if you look at, I think this is a 32 spline. If you look how large that is, and then you look how much larger the 6L90 is, I think you can recognize that that's really not needed. So we can support you with a 6L90 if you need it, but really the 6L80 is more than enough. It's not as long of a transmission, it's not as heavy as a transmission, and I recommend you go with it. All right, so that's pretty much what's going on in the shop today, and we'll be seeing you soon with some videos on LT4s.